If I told you there's an engineering field responsible for your car, your phone, your washing machine, and every industrial robot on Earth, and most people have never heard its name, would you believe me? It's called Mechatronics. And by the end of this video, you'll understand it better than most engineering students do in their first year. Let's start simple. Mechatronics is the fusion of 4 disciplines: mechanical engineering, electronics, computer science, and control systems. It's not a subfield of one of those. It's the overlap of all of them. Here's the core idea. A purely mechanical machine can move, but it can't decide. A purely electronic system can process, but it can't act. Mechatronics is what happens when a system can sense its environment, decide what to do about it, and physically act, all in a loop. That loop is the entire point. The term was coined in Japan in 1969 by an engineer at Yaskawa Electric, blending mechanics and electronics. It sounds recent, but the idea is decades old. It just took off as machines got smart enough to need it. Before computers were cheap and small, machines were either fully mechanical or fully manual. Mechatronics only became a real field once computing got small enough to live inside a machine.
People often confuse mechatronics with robotics. Robotics is an application. It's what you build. Mechatronics is the discipline. It's how you build it. Every robot uses mechatronics principles, but not everything that uses mechatronics is a robot. A smart thermostat, an anti-lock braking system, a 3D printer, none of those are robots, but all of them are mechatronics. Every mechatronic system runs on the same loop. Sense. Sensors gather data from the real world: temperature, position, pressure, light. Decide. A controller, usually a microcontroller or computer, processes that data and decides what should happen. Act. Actuators, motors, or output devices carry out that decision physically. Your car's anti-lock braking system is a perfect example. Sensors detect wheel slip. A controller decides to reduce brake pressure. Actuators pulse the brakes. That entire exchange happens faster than you can blink. You interact with mechatronics constantly without noticing. Your phone's camera autofocus, sensing light, deciding focus distance, moving the lens. Industrial robotic arms on assembly lines, sensing position, deciding trajectory, executing movement with sub-millimeter precision. Modern prosthetics, sensing muscle signals, deciding intended movement, actuating a mechanical hand. This is why mechatronics engineers are in demand across almost every industry: automotive, aerospace, medical devices, consumer electronics.
As automation and AI convergence accelerate, mechatronics is becoming the backbone discipline of Industry 4. Every smart factory, every autonomous vehicle, every next-gen robot needs engineers who can think across mechanical, electrical, and computational boundaries at the same time, not in silos. That's the real value of this field. It doesn't ask, how do I build the strongest part? Or how do I write the smartest code in isolation? It asks how all of it works together. So next time you use autofocus, cruise control, or watch a robotic arm on a factory floor, you're watching mechatronics in action. If you want the next deep dive into how a specific sensor or system works, subscribe. That's exactly what this channel is built around.